Hi, this is Dr. Staley. I'm recording this out. I'm recording the audio for this afterwards because the lapel mic I was using at the time apparently did not work. So this is the synthesis of nickel complex salt A. Here I've got the solid nickel 2 sulfate hexahydrate. I'm adding it to the beaker. Sometimes when you try to add a solid to a piece of glassware, you can have a problem with static electricity causing some of the solid to stick to the sides, and even the annoying part where it sticks along the rim and moves to the outside when you try to push it in with a spatula or a scoopula. That doesn't usually happen with beakers, so it's not that big a deal. Now here I'm about to go and get the 5 milliliters of deionized water. So this is 1.25 grams of nickel sulfate hexahydrate, and I'm adding water to it to dissolve it so we can actually do the reaction. One of the things about adding water is that we want to add enough to dissolve the solid, to dissolve the reactant, but not so much that we have a hard time getting the product out of solution afterwards. Now that means that I actually have to stir it for several minutes here, but because I just kind of, yeah. Oh, there we go. So I cut through most of the stirring, and now after a couple of minutes, the solution is this color. You can see there's no solids in it. And it is time to add the other reagent. Now the other reagent is ethylenediamine. Ethylenediamine has a fairly high vapor pressure, which means that I don't use it out on the benchtop. It stays in the hood at all times. So I'm going to actually go over there and measure, I think it's 1 milliliter of it out, and pour it in. There we go, moving it. There we go. Now in that hood on the left hand side, I've got the ice bath with the ethanol, with the uh, bottle of ethanol in it, and on the right hand side, I've got the bottle of ethylenediamine in and a beaker right next to that. Here we go. Let's get that. Pour it into the beaker, pour it from the beaker into the graduated cylinder. Close that up. Okay. So I've got it there, and I'm going to pour it in to the beaker that has my nickel solution. Now, when we first add the ethylenediamine, there is a high concentration of the ethylenediamine wherever it happens to hit the solution. And as a result, a whole bunch of it is going to grab the nickel in that area and is going to precipitate it. That's why there's another couple minutes of stirring here to get that precipitate to dissolve so that the ethylenediamine can actually spread out enough so that we can get the ratio of nickel to ethylenediamine that we actually want. And here I'm putting the whole solution into the ice bath. Now, what we want to do is we want to get the complex salt and we want to get it out of the solution. This step involves, so what that involves is forcing it to crystallize and then filtering out the crystals later. Now, solids become less soluble at lower temperatures and more soluble at higher temperatures when they're in a liquid. For gases, it's actually the other way around. They become less soluble at higher temperatures, more soluble at lower temperatures. But in any case, by leaving the beaker in that ice bath for at least 30 minutes, we should get some precipitation. And here I've got a bottle of 200 proof ethanol. That's absolute ethanol that has been sitting in the uh, ice tub all this time. And I'm going to add some ethanol to the solution in order to force the salt to precipitate. Because this particular salt that we're using is less soluble in ethanol than it is in water. There we go, put it back. There's that beaker with the product mixture in my left hand. In my right hand, I'm adding the ethanol while stirring. Adding it very slowly while stirring. Stir a little bit more. Okay, so there's a cut right there. That cut hides about 35 minutes of just kind of waiting for the crystals to form and, going off and doing other things. So here I've got the vacuum filtration set up already, put together and set up. And there in my left hand is the product mixture with the nice little crystal precipitates. There we go, nice precipitates. So here I'm turning on the vacuum to the vacuum filtration setup. And I'm prepping the filter paper with the solvent. And now here I'm very slowly adding the product mixture to the Bruckner funnel that has the filter paper in it. Now, I don't want to dump it in all at once because then I risk splashing, then I risk losing some. But also, if the total volume in there gets too high, then it might go close to the edge of the filter paper. And that means that some solid might end up getting around the filter paper. We don't want that. There we go. So I've got some solid left there. Now what I'm going to do is I'm going to scrape that out with my scupula. Ideally, what I would want to do is I would want to take more of the solvent that I was using for the procedure and use that to kind of get everything off the walls and dump it in. But the problem with that is that this salt is fairly soluble in that solvent. So I don't want to do that because then I'll get some dissolved and I'll have a lower yield. So instead, I'm moving as much of the solid as possible just in bulk, in one piece. And making sure to rinse the spatula down so any crystals that were stuck to it end up on the filter paper. And I'm just making sure that any little pieces got taken off the sides. Doing this once isn't really that big of a deal. Doing it twice also isn't really, that big of a deal, but when it's the only thing that you're doing to get everything out, then it can become a real problem. And here now I'm washing with my 2 portions of 5 milliliters. You can see on the bottom there that some solid actually did manage to get through. More likely what happened there in the bottom of that vacuum flask is that some of the solid was dissolved, some of the product was dissolved, and then it came down. And then once it went down into that flask, the fact that the pressure in that flask is constantly being pulled off means that that flask is a lot colder than the air around it. So what probably happened there is that some of the product was dissolved in the water, then it went through the filter, and when it reached the bottom, it precipitated out. And here I'm just showing you from the top. Come on, old me. There we go. Yeah. So the salt is concentrated in the center of the filter paper, and it's nice and blue. And that is that for today. I'm going to leave that on the filtration on the vacuum for a few minutes, and then I'm going to take it off. I'm going to put it in the hood and let it dry off until the next day.